Yes.
You showed a sequence of successive universes, one after the other.
Yeah, I'm calling them eons of our universe, you see that, yes.
Yes.
Because we're really connected, yes, go on.
I can see how the sequence proceeds, but I mean, the obvious question is, where does it all start? I mean, and
Well, you see,
what is that significant event that starts it all off?
Well, the philosophy here, although in detail completely different, is like the old steady state model. That was one of the reasons. You know, when you go back and you think of what Newton thought of what Einstein thought, they were very happy with a universe which was there all the time, you see. And there wasn't a beginning. In fact, Einstein fought against, when Lemaitre tried to convince him that there really was this, what we now call a Big Bang origin, he didn't like the idea at all, but he had to be converted to it by the equations seem to tell you that you can't get away with it otherwise. And then people got accustomed to the Big Bang being there. Or not just being there, you see, I'm claiming it is there, but it's not the beginning. So the argument, as you say, is like, well, where did it come from? Well, it came from the one before. Where did that come from? The one before. I once had to give a talk about this in the Vatican, and I was rather nervous about what they would say, you see, because Lemaitre was a priest, and the arguments often took a kind of religious tone, you see. If you believe in the Big Bang theory, you've got to believe that God was there first to make it. If you believed in the steady state model, it was all right not to have a God, you see. So that got messed up the argument, rather, with what you should do is look at the data and all that stuff. So it's the same argument. There doesn't have to be a beginning. It was just always there. But when I was in the Vatican, I thought I was going to be pounced on by these people. You see, they say, no, you've got to... No, they took what, from my point of view, is the correct answer. I should say from their point of view, the correct answer, no. God created the whole thing, you see. Well, I suppose he could do that too. So I don't think it's a religious point, you see. I think it's can have been all there for all time. Einstein tried a steady model which was supposed to be stationary for all time. Newton thought that a similar sort of thing. He thought if there was a bit of instability, God could come in and fix it up again and let it keep going, you see. So this seems to be a view that other people have held before quite happily, that there could have been an eternal universe, and this is just a little more complicated version of an eternal universe. Thank you. Sorry, I should let other questions come in.
Thank you. It's a great talk.
Thank you.
I'm not sure if I have fully understood what you said, but are you saying that the universe is therefore not expanding?
No.
And does that then remove the need for dark energy?
No, I'm accepting that there, I don't know, you probably weren't here at the previous discussion we had. No, I'm taking the view that what people call dark energy is what Einstein introduced in 1917 for the wrong reason, the cosmological constant. And that is a way of modifying Einstein's original equations. It's about the only way you can do it without wrecking them. So it was a good idea and put in for the wrong reason when he originally introduced it. He claimed it was his worst blunder, but in fact it probably seems to be true. I mean, there's still argument about that, but it's pretty clear that there is something going on which looks like the cosmological constant. Now I've forgotten your question. What was it again? Sorry. Yes.
The fact that you're showing these repeated universes over eons as effectively cylinders,
Yes.
if that's intended to be a literal interpretation.
It's a conformal interpretation. Literally,
Right.
see, you might think, when you have mass around, then you've jolly well got to have the expansion. You see, because
Right.
then you can measure distances. And once you can measure the distances, then, okay, it's expanding. It's only here, I claim, when you can't measure distances, when there's no mass around, then it becomes indeterminate how big it is.
Right.
In a certain sense, the universe forgets how big it is. That's a sort of anthropomorphic way of saying it. But I'm saying that the scale becomes unfelt by the universe because there's nothing which gives you a scale. The mass is not there. So
Right.
big and small become physically equivalent.
And so, sorry, if I could just expand that further. Are you saying that it would have expanded, it had to expand to get to that point where scale ceases to be relevant?
Well, when there's mass around and it has to come in, you know, it's something to do with Higgs particles and so on, when it comes down, the temperature comes down below the Higgs temperature and things. That's a particle physics question.
Right.
And according to that, the mass will come in at a certain point. Before that, you have a situation where the scale of the universe is not determined. And so the idea is in the future it's not determined, in the beginning it's not determined, so I have the freedom to match them up. And the idea is that the equation, you've got to go into equations here and make it work. And you can make it work. There are some questions that they're still around about that, but it's something you can make sense of.
But you would still need dark energy to...
Yes, the dark energy, I don't like the term because it's neither dark nor energy, but apart from that, it's what I call, what people used to call the cosmological constant. I mean, it might be not that, but it's completely consistent with that at the moment. So that has to be there, because this makes infinity to be the right shape, so to say. It doesn't work otherwise. If you didn't have it, this model would not work.